Okay, so let's try to work through your starter questions and find the answers. So for 1a, we've got sine theta, which is an original, so I'll keep it as it is. Cot, which is either 1 over tan or cos over sine, so I'm going to use cos over sine because we've already got a sine here. Those two will cancel out and leave you with cos theta. Nice and easy. Tan theta and cot, oh, that's easy. So tan is an original function. Cot is 1 over tan. You can see that if you times those together, those will cancel out and leave you with 1. You might have said tan was sine over cos, and cot was cos over sine. But even if you did it that way, those two would cancel and those two would cancel and leave you with 1. So no matter which of the ways you did it, you'd still end up with the same answer. Okay, for part C, we've got tan 2 theta, cosec 2 theta. So tan 2 theta is sine 2 theta over cos 2 theta, and cosec is 1 over sine, so 1 over sine 2 theta. And then that will cancel with that and leave you with 1 over cos 2 theta. And we know that 1 over cos 2 theta is the same as sec. So it's sec 2 theta. Okay, and that is simpler than that. For D, sec A minus sec A sine squared A. That's got a common factor. The common factor is sec. So if I take sec A out as a common factor, I'd be left with 1 minus sine squared A. We know that 1 minus sine squared is cos squared, so I'm left with sec A cos squared A. Sec is the reciprocal of cos, so 1 over cos A times cos squared A. That cos there is going to cancel with that cos there, so you are left with cos A. And the last one, if you can still see that, I don't think you can here. I do that way, is that better? Right, this looks horrible, but it's probably turned out to be quite straightforward. So sec is the reciprocal of cos, so that's the same as 1 over cos squared x, cos 5x. Cot could be 1 over tan, or it could be cos over sine. I'm going to use cos over sine because I've got a sine here, and I've also got a cosec here. So that's cos x over sine x times cosec, which is 1 over sine x, times sine to the power of 4x. So 2 of those are going to cancel with that and leave you with cos cubed. 2 of those are going to cancel with that one and leave you with sine squared. So we've got cos cubed plus cos x sine squared x. In here, we've got cos as a common factor. If I take out cos x, I've got cos squared x, which would give me that term, plus sine squared x. We know that cos squared plus sine squared is 1. So we've got cos x times 1, which is cos x. So much nicer than this horrible thing up here. Okay, let's look at question 2 then. Right, so with the proved ones, remember you start working on the left-hand side and you turn it into the right-hand side. So I'm going to leave cos as it is. I'm going to leave sine as it is. and I'm going to turn tan into sine over cos. So this gives me cos theta plus sine squared theta over cos theta. It's still not looking much like sec, so I'm going to put these over a common denominator. So if I times this side by cos x over cos theta over cos theta, it's going to give me cos squared theta over cos theta plus sine squared theta over cos theta. Because these have a common denominator, I can add them. You know that cos squared plus sine squared is 1. So that's 1 over cos theta, which is sec theta. So that's where that comes from. So it doesn't look like it's going anywhere. Turns out nicely. So sometimes you've just got to have a bit of faith and see it through. On this side, we've got cot. Right, so we've got cot and tan, which we could write as functions of tan, but on this side we're aiming towards cosec and sec, which is sine and cos. So I am going to be trying to write these in terms of sine and cos. So cot is cos theta over sine theta. Tan is sine theta over cos theta. So I'm starting with the left-hand side. I do something to it. Hopefully I'll end up over here. I'm going to cross multiply these. So I'm going to times this side by cos theta over cos theta and this side by sine theta over sine theta. So I'll be ending up with cos squared theta over sine theta cos theta. On this side, I'll be ending up with sine squared theta over sine theta cos theta. So I've got a common denominator here, so I can add the numerators. We know that cos squared plus sine squared is 1, so I'm left with 1 over sine theta cos theta, which is near to this, because cosec is 1 over sine and sec is 1 over cos. So if I rewrite that as 1 over sine times 1 over cos, I've got 1 over sine, which is cosec, and 1 over cos, which is sec. And let's try these last two. So if I multiply this out, I'm going to have 1. So 1 minus cos x plus sec x minus cos x sec x. Cos x sec x, I'm just going to look at that bit. Sec is 1 over cos. So you can see that those two are going to cancel out to leave you with 1. So you've got 1 minus cos x plus sec x minus 1. So 1 and minus 1 are going to cancel out, and you are left with sec x and minus cos x. So sec is 1 over cos minus cos x. Okay, if I times this side by cos x over cos x, see what happens to that. So I've got 1 over cos x minus cos squared x over cos x. Oh, okay. So now I've got 1 minus cos squared on the top, which we know is sine squared. I've got cos x on the bottom. So I've got sine squared over cos. I've missed my x off, which looks a bit like this because I've got the sine in. If I rewrite that, sine squared x is sine x times sine x. So if I rewrite that as sine x over cos x times sine x over cos x is tan, sine is sine, so it leaves me with tan x sine x, which is what I want up here, just written the other way around. Okay, and the last one see that okay? So for this one to end up here, I'm definitely going to have to cross multiply. So I'm going to times this side by cos x over cos x, and I'm left with cos squared x over 1 minus sine x cos x. If I times this side by 1 minus sine x, I've got so now it's a common denominator, so I can add the numerators. I'm also going to multiply these out, so I've got 1 minus sine x minus 2 sine x. Nope, minus 2 sine x plus sine squared x. Got something wrong with the sign here. Okay, I'll come back to that in a second. So cos x plus sine x is 1. So I've got cos squared x plus sine squared x is 1. So 1 plus 1 is 2. So I've got 2 minus 2 sine x. No, I haven't. 2 minus 2 sine x over 1 minus sine x cos x. It's got a common factor 2, so I can rewrite that as 2 1 minus sine x over 1 minus sine x cos x. Those two will cancel out. I'm left with 2 over cos x, and anything over cos is sec, so I'm left with 2 sec x. Now when I got to here, I thought, oh, that negative there, I haven't got a negative in the answer, I'm doing it wrong. Actually, I wasn't, so please have some faith with yourself. You know, you might get to a point in the middle, and likewise on this question here, or any of the others where you think, I don't think this is working out how I think it should. Please try to see it through to the end, because very often turns out you're right after all. And if it doesn't, then you can go back and change something that you've done. But don't have the confidence to carry it through, and don't have a big panic in the middle. Okay, I hope you got on with those okay.